Hello everyone, welcome back to MAC1105. Before I start the video, I just want to say sorry for this inconvenience. Recently I have a very bad allergy, so maybe in the video you will hear I'm coughing a lot. So again, I'm sorry for this inconvenience, okay? In the previous video, we already talked about function, and we know the definition of function already. Now, let me start the new topic today by giving you a sketch. So I have a sketch like this. Okay. I have a sketch. I have y coordinate system. And I have the picture like this. Here you go. I have the graph, and we know that if we apply the vertical line test, we know right here this is a function. Now I'm gonna go ahead and mirror this graph through this line right here. The line right here is y equal x. And because the line y equal x over here is 45 degrees, so they divide 90 degrees into half. So I'm going to mirror this graph right here, which is the function, and name is function f of x. So I'm going to mirror this one. So I will have another sketch because I mirror them. So I will have something like this. Right? So I will have something like that. Kind of something like this. There you go. And if you see that if you apply the vertical line test over here, my vertical line test also cut the yellow sketch right here at one point. So this one also the function, right? And I name this function is g of x. Okay. And actually g of x over here is called the inverse function of f of x. Okay, and in this video today I will be talking about the inverse function. So this is g of x is inverse function of f of x. Okay. So as we already know, not all the relation is considered as function. It must satisfy one of the condition, right? And the same thing for inverse function, because not all the function has inverse. So in this video, I'll be also talking about the condition when the function has inverse, and also as the characteristic of the inverse function. Okay, so let's put out the topic today. Okay, inverse function. Inverse function. Before talking about the definition of inverse function, I just want to talk about another definition. We need to know what is one-to-one function first, because for a function to have inverse, it must be one-to-one function. But what is one-to-one function? So on the first part of the video, I just want to talk about one-to-one function. One-to-one function. So what is one-to-one function? According to the definition, it says that for a function f is one-to-one function, then if a and b is considered as a domain, as the element of the domain, and a is different from b, then fa is different from fb. So that's the definition. Okay, if f is one-to-one and a b belong to domain, okay, domain of f, and a is different from b, then f of a different from f of b. So this is the mathematical definition of one-to-one function. And we can use this definition to check if the algebraic function is one-to-one function or not. But how are we going to understand this definition? As we know that for a relation to be a function, then for each input is assigned a unique output. One unique output. Okay, one input assign unique output. Okay, if you have two different input and it assign the same output, it's still called a function. Okay, but that is not one-to-one function. That's what I mean. So actually, one-to-one function is for each value that assign the y value, and for each y value corresponding back to that x value. So that is more important than this definition, because it helps us to understand what one-to-one function is. So one-to-one function is a function where it has for each value, for each x value, okay, it is corresponding, okay, it corresponding to a y value, okay, and for each y value it is corresponding, excuse me, to a x value. So this is it. If it has this condition, if it is satisfied, if a relation satisfies this condition, then that relation has inverse. That relation has inverse. It means that function has inverse. Okay. Now let me give you the example. Let me give you the first example. And in this example, I'm gonna give you the one of the method of representing a function. So I have something like this, and I have two. This is domain set input, and this is output. So this is domain, and this is range. Okay, and in this image I have 1, 2, 3, 4. Okay, and over here I have 6, 8, 9, and 10. Now this one assigned to this. Okay, this one assigned to this. This one assigned to this. Alright, this one assigned to this. Okay, and let's put another one, or maybe I will just put another point right here. And this one assigned. Oops, how we go back? Oh my god. Let me go back. And this one is assigned to this. So we know that this is a function, but you see that 2 assigned to it and 3 assigned to it. It contradicts to this statement, because according to this statement, it says that for each x value, it corresponding to a y value, and for each y value, it corresponding only to one x value. I'm gonna put over here to corresponding to only. I'm gonna put only x value, one x value. Let me write it. It corresponding to only one x value. There you go. This is it's better. This is only to only one y value. For one x value, or one y value. But the thing over here, if you look at this, 2 assigned to 8 and 3 also assigned to 8. So we have, it contradicts to this because for each input is assigned only one y, but this for only for y it assigned, it corresponding to only one x, but the y over here it corresponding to 2 and 3. So the function f here, function f here is not 1 to 1 because it is corresponding to not 1 but 2 value, 2 x value, which is in this case is 2 and 3. Okay, so this is not 1 to 1 function. Okay, so this, even though this is still a function, this is still a function. This is function, but it's not 1 to 1 function. And because it's not 1 to 1 function, so it does not have inverse. Because for a function to have inverse, it must be 1 to 1 function. Okay. Now let me give you another definition. This is the second method of representing function. I have a relation like this. I have how about if I have something like this? I have a relation f. It's a collection of points, and it's, the first one is the -1, -2 1, -1 0, 0 1, 1 2, 1 2, and 2 2. So I have collection of 5 points right here. And now if you look at this, okay, first of all let's check if this relation is function or not. Okay, this relation is function, yeah, because we have each input assign unique output. None of the input over here give you 2 outputs, so this is a function. So f is a function, but let's see if it has inverse function or not. Let's say if it is 1 to 1 function. So you see that right over here. You see that, okay, output over here, okay, output over here 2. So f is not 1 to 1 because we have 2, because 2 is corresponding to 2 value, which is 1 and 2. It contradicts to this. It contradicts. You see that? 2 right here. 2 right here. Okay. It has 1 and 2 goes into that. Okay. So it contradicts to this. Besides, you also see that right over here, this and this, you see there's also 2 value, -2 and 0. So there's over here, I can say, because 1, because 1 is corresponding to 2 value, -2 0. Okay, so even though it's a function, but this is not 1 to 1 function, and because it's not 1 to 1 function, so this function over here has no inverse. Okay, so that's the purpose of 1 to 1 function, because for function to have inverse, it must be 1 to 1. Okay, so this is so f function f has no inverse function. Okay, has no inverse function. Now on the third example, I can use the definition of one-to-one function to check if the algebraic function is one-to-one or not. Okay, determine if the following function is 1 to 1. Now let me give you this: f of x equal to negative 4x plus 12. So according to the definition of one-to-one function, it said that if a different from b, then fa different from fb. So I just pick two values. A and b belong to the domain. Now let's check f of a. F of a we plug it in. Okay, f of b we plug it in. Now if a is different from b, so do you think this is different from this? Negative 4a plus 12. Okay, and negative 4b plus 12. Okay, it is, because you see that 12 and 12 cancel out, so we have a different from b. Okay, so that is just, I just prove it, because I just show that if a fa is different from fb, then a different from b. Okay, you can do the other way around. You can do if a equal b, then fa equal to fb. That's the same thing. Okay, but you can, I think you can do like this. I think with this symbol it's much better, because we try to follow the definition strictly. So you see that if fa different from fb, then fa different from b, then a different, and that's actually, it means that this statement and this statement is go both way, both direction. If a different from b, then fa different from fb. If fa different from fb, then a different from b. Of course, over here a different from b, because we write fa equal different from fb. Then over here we show that a different from b. So of course, so fx is 1 to 1. Okay, you can use number to check if you want to. Okay, how about this one? I'm going to do the same thing. Determine if the following function if the following function is 1 to 1. So I have radical function. Alright, so let's start. Okay, let's start with GA. Okay, GA, you're gonna plug it in, and GB we plug it in. So if we can show the GA different from GB, given GA, if we can show the A different from B, given GA different from GB, then we're done. So if okay, it's different from this, And now we can show A different from B if we go ahead and square them. Okay. And when we square them, which is give you 25 minus A squared different from 25 minus B squared. So cancel this, so you have negative A squared different from negative B squared. So A squared different from B squared, then A different from B. Alright, so I just saw that given G of A different from G of B, we get A different from B. Okay, so this one, then G of X is 1-to-1 function. Okay. Okay. Well, if they give you the graph, this is algebraic function. But what if they give you the graph? And how we know that this is 1-to-1 function? Also, it's very easy. We gotta apply a test called horizontal line test. So I'm gonna put the first remark right here. Remark number 1, horizontal line test. So the horizontal line test shows that if we put a horizontal line and we cut the graph at more than one point, so that graph is not 1-to-1 function. It's not 1-to-1 function. Maybe it is 1-to-1. It's not 1-to-1 function, so it does not have inverse. But if I give you the sketch like this, what if I have this? I have a parabola, and see that if I apply the horizontal line test, you see that I cut at 2 points. Okay, I cut at 2 points. So that's why I can say that. Okay, f of x here is not 1-to-1, and because it's not 1-to-1, so f of x does not have inverse function. So you know up to this point you know right away that not all the function has inverse, even though it's still a function. So there's a lot of function that does not have inverse. It's not 1-to-1. For example, parabola or absolute function. If you put a horizontal line there and cut at 2 points, so this absolute function is not 1-to-1 function, and that's why it does not have inverse. And we there's a lot of them, not just 1 or 2 or 3, but many function is not does not have inverse. Okay, so if they give you the sketch, that is one of the best way to check if it has inverse or it is 1-to-1 function or not, by using horizontal line test. Okay, if it cut more than 1 point, that does not satisfy horizontal line test. Now, so after we already know what 1-to-1 function is, now on the second part, we're going to talk about the inverse function. Now we're going to talk about mathematical definition of inverse function. So inverse function is a function. Okay, it's a function graphically obtained, can be obtained by drawing the image, okay, of the original function to the line y equals x, and the inverse function is notated as f of raised of f of negative 1, f raised to negative 1 of x. I'm sorry. So it could be written as given y equal to f of x. Okay, then inverse function of f is notated. Inverse function of f of x is notated as f of raised of -1 of x. Okay. So this is the definition of inverse function. Okay, -1 of x. So what does it mean by that? It means that the domain of inverse function will be the range of the original function. Okay, in the range, the domain of original function will be the range of the inverse function. So if y equal to f of x, then we can write it. Okay, then we can write f of -1 of y equal x. Okay, f -1 of y equal x. For example, what if I have f of 1 equal to, okay, then based on the definition of inverse, I can write f of -2, f of f raised to -1 of 2 equal 1. Okay, we can do like that. That's because the domain, the range become the domain. You see that? And the domain become the range. So this is an inverse function. It's an inverse function. Okay. Besides, we can also say that given two functions, okay, given one given function f, function f, and f is one-to-one function, then we can name the inverse function as the function g. Okay, and if we compose f to g and g to f equal to x, okay, then they are inverse of each other. Okay, so it's the first definition, or the second definition you can put like this. Okay, if f is 1-to-1, then g is inverse function of f if f composed to g equal x and g composed to f equal x. Equal the identity function. Okay, so this is we're gonna use this to check if the two functions are the inverse of one another. We can use this. Okay. Okay. For example, given two functions, f of x is x to the third minus 1, and g of x equal to cube root of x plus 1, and we want to check if f of x and g of x are inverse of each other. Okay, answer. So we're gonna compose f to g and g to f. If it's down to a to be x, then they're inverse. Okay. First of all, compose f to g first. So I'm gonna plug them in. So I have cube root of x plus 1 raised to the third give you x plus 1 minus 1, which is x, which is good. But we gotta do the second one. So f to x. So I have cube root. Okay, I put the whole function over there. So x cubed minus 1 minus plus 1 cancel. I have cube root of x raised to the third, which is x. Alright, so this turned out to be x. So we can conclude. So f and g are inverse of each other. There you go. Inverse of each other. Okay. Well, so with this definition, we can check any two functions are inverse of one another. Okay. So on the secondary mark, I already said it. I'm gonna put it over here. Number 2. Okay. The first remark I want you guys to notice that the f of raised -1 of x is not the same as 1 over f of x. Okay, it's not the same. So the -1 over here doesn't mean that's a negative exponent and you flip it. No, it doesn't mean that. And secondly, if f and g are inverse of each other, then domain of f is range of g and range of f is domain of g. Okay, so I mean, if they give you the graph, you probably can use this remark here to find the domain and the input and output. We can find it. It's kind of similar to the first example here. Okay. Okay. Now in the next example, let me see, I can give you another one. This is example 2. I can give you another one that's similar to example 2, but the function is harder. We check the inverse of each other. Okay. Example 3. So given two functions like this, f of x equal to x minus 3 over x plus 4, and g of x equal to x plus 3. Let's check if f and g are inverse of each other. So we're gonna do the same way as we did in example 2. We're gonna compose those functions together to each other. Okay, so let's compose f to g first. Okay, so g look into the f. So I have 4x plus 3 over 1 minus x minus 3 over 4x plus 3 1 minus x plus 4. So this is just require you to simplify a rational expression. So over here I have LCD 1 minus x f(4x plus 3 minus 3, 1 minus x). Finding LCD. Finding LCD over here. So I have 4x plus 3 plus 4, 1 minus x. Keep chain flip. Distribute it. So I have 4x plus 3 minus 3 plus 3x over 4x plus 3 plus 4 minus 4x. So they cancel out. So I have 7x. Okay. And this is cancel out. I have 7. So I simplify that with UX. Okay. Now we gotta do GOF. You gotta do both. Okay. So this into this. So I have 4 x minus 3 x plus 4 plus 3 over 1 minus x minus 3 x plus 4. Finding your CD. So x plus 4 f(4x) minus 12 plus 3. In the bottom I have finding LCD. I have x plus 4 minus x plus 3. Distribute the minus in. So I keep chain flip. So I have 4x minus 9 over 7. So you see that number 42, example 3. I'm sorry, example 3 is not one-to-one function, because when you compose it, let me see if let me check one more time, because look at I think I have some careless mistake over here. Minus 3 x plus 4 minus plus 3 4x minus 12 7. Okay. I don't think I have anything wrong, right? It's 4x minus 3 x minus 3x plus 4 times 4 over there. Oh yeah. I forgot to find LCD here. So x plus 4 right here. So I have minus 12 plus 3x plus 12. Okay, so I have 7x over 7. There you go. Alright, then F and G are inverse of each other. Okay. So far all the example we can see, and we can use horizontal line test to check if it has inverse or not, or is it one-to-one or not. But what if it is one-to-one and it has inverse? Then how are we gonna find that inverse? Okay, so in the next example, okay, I'm gonna show you how to find the inverse of the function. Of course, that function must have inverse in order to find inverse. If it does not have inverse, then what is the point of finding inverse, right? Alright, find inverse of function f of x equal x squared x minus 2 raised to the third. So in order to find inverse, the first thing you have to do is you have to change f of x into y. Then you swap between x and y. So y become x become y. Then you try to solve for y. It means you try to get the y by itself, so in a literal equation. So you're gonna take square root both sides in this case. So we have square root of something square, which is given to itself. Okay. So what I have right now is square root of x equal y minus 2. And from here you can get the y. It will be, you add both sides by 2. So you have 2 plus square root of x. So this is a function, inverse function. So this is inverse function of f of x. Okay. But the thing is, some function is very hard to find inverse. Okay. Of course, in that case, it's not a part of our pre-calculus or college algebra. If I ask you to find the inverse, it means that function is you can find it. It means you can find it. Okay, because some function we know that it has inverse, but it's very hard to find that inverse. Okay, but in many cases, if the question asks you to find inverse, it means that it's feasible to do it. Find inverse of g of x. 3 x minus 4. Okay, do the same thing. You're gonna just go ahead and change it to y. Then you swap it. X become y, y become x. Then you try to get the y by itself. So I do cross multiply here. So I have okay. Then you distribute it. Okay. Then you see it over here. We have two terms with y. We have to get them together. Subtract both sides by 2y. Then in order to subtract this, we're gonna factor the y out. Okay. Then from here, I can get y by itself, which is 4x minus 3 over x minus 2, which is also the inverse function. Okay, so that is all the step of finding the inverse function. You could just do the same thing for all functions, but again, some of them is very hard to find the inverse. In many cases, if I ask you to find the inverse, it means it's feasible to find. Okay, it's feasible to find. So don't worry about that. Alright, so I'm gonna stop the video right over here. Please let me know if you have any question on the inverse function and how to find inverse function. Just send me the message through Canvas. Okay, I'll be seeing you next time. Bye bye.